Hey class, so today I wanted to make a video going over Desmos. So first I wanted to apologize if my video from yesterday um, was a little low energy, if I mumbled a lot. I was making the video pretty late, so I didn't want to be too loud. But making this video a lot earlier today, and since in yesterday's video I kind of covered both today and yesterday's objectives, I wanted to make this video about something that could help you guys understand the material a little bit better and also help you through any of these homeworks if you ever get stuck. So, for example, the homework that was due today on amplitudes, um, that's going to be multiplying the sine function by a number. So something like 4 sine x. Okay. Now, maybe before we run into doing all these examples, I should kind of give you a rundown of what you can do to make this graph look a little bit more appealing or be a little bit more helpful. So the first thing is there's this little wrench in the top part of the screen that you can click. And since we are since we are dealing with radian measured angles, and one of the methods that we use in order to graph these functions is using the 5/4 points. It's best to set the step right here with your x-axis to pi over 2. So what that does, as you can see, is it makes these thick lines right here that break up the x-axis into pi over 2. And it does that for the entire x-axis. So you can keep going, you can zoom out, everything like that. It's all going to be in pi over 2. So once we've done that, we can also do a couple more things. First of all, I kind of like this grid. This grid's a little confusing, so make sure you're on this grid. The second thing you can do is you can always go in and change your x-axis range. So in some of the problems, you wanted to look for certain coordinates in a certain range of values. So I think one problem was looking for zeros in the 3 pi range, and the range, what was it? I think it was something like 7 pi over 4, something like this. And when you do that, if you were looking at the sine function, so let me highlight what I did. So first of all, I went to these values right here to the left and right of the x variable. And in order to get pi, I just typed in pi. So if you type in p, then I, it automatically converts it to a pi. And what this does is it cuts the graph off on your screen at -3 pi and 7 pi over 2. Okay, so this allows you just to look at the graph between the range that you're looking at. And this is really helpful because if you're looking for these zeros, you can go in here, and since this is a 0, this is where the y coordinate is 0, correct? Yeah, so it hasn't moved up any. We see that this is at -2 pi. And similarly, you can click on this point right here and see it's -pi. So once you click on a point, it will keep the value up, coordinates up, until you click on it again. So then it goes away. So this is an easy way to double check your work, or if you're stuck and have no idea what to do, this is a way to find the answers, and then maybe you can try to backwards solve it, right? Try to see, okay, well, how could I have gotten these values? It also highlights the maximum and minimums here. So this is another way of looking at the 5/4 points. So if I go from 0 to 2 pi, let me do that in the settings. So if I go, let's just say we wanted to look at the first cycle of this sine wave, 0 to 2 pi. Oh, what did I do? Okay, there we go, much better. So this is the first wave of our sine wave. And now we can highlight just the quarter points. 0, 0, pi over 2, 1, pi 0, 3 pi negative 1, and 2 pi 0. So Desmos is also really good for doing anything with the 5 quarter points. Okay, so now that we've got those basics down, pretty sure that's everything. Yeah. Let's talk about the newer homeworks when you're dealing with sine and cosine that are kind of multiplied by numbers. So if we have an amplitude of 4 sine x, you can see that the only quarter points that have changed are the pi over 2 and the 3 pi coordinates. Right? Oops. So these zeros did not change at all. Sorry. I'm using a touchpad right now. So it's being difficult. Okay. So as you can see, comparing these 5 quarter points to our old 5 quarter points, and you can do that by clicking this plus button and adding an expression. These points are the only ones that changed. The zeros are exactly the same. And they changed by exactly a factor of 4. So all you do is multiply these 1s and negative 1s by 4. So we can also look at what happens when we do a negative. Maybe I should have kept that. Let me rewrite that. So what if we do a negative? Let's see what happens. Okay, so now not only did our point get multiplied, well actually it did just get multiplied by this negative 4 on the outside, but what happened is the function actually flipped. And it's exactly mirroring what this function looked like, except it's the reflection across the x-axis. So I can just sit here, delete this negative, add the negative, and you kind of see how it flips back and forth. So this is the basics of amplitude and what it does to our graphs. When we multiply it by a positive number, nothing changes about the graph except how high and how low it goes, right? However, if we multiply it by a negative number, then we change not only how high and how low it goes compared to the x-axis, we also change the direction in which it starts. So the cosine function starts going up when it's a positive, but when you multiply it by negative, it goes down first. So you change that. Okay, and that is the basics of this. This is the same if we did a cosine function instead of a sine function. So the cosine function originally looks like this, right? So the 1 points are now these 2, and they've just changed by a factor of 4 here. But when I multiply it by a negative 4, they flip. So the positive 1 here becomes a negative 4. So it does the same thing to sine and cosine. But remember that sine and cosine have different 5 quarter points. So it is still slightly different. Okay, so now let's talk about what happens when I do cosine of x and multiply this x by a number. So let's start by just multiplying this by 2. Okay. Let's then compare this to cosine x just to see how this has changed. Okay, so let's change our range to 0 and to pi in order to see what's happening here. So you can minimize this by just clicking that. Now these are the functions from 0 to 2 pi. Okay, this red one is our cosine x, and this purple, I guess that's purple. This purple one is cosine of 2x. So notice that, oh, I can't highlight here, but notice that this section of the purple graph is one complete rotation. So this purple shape is exactly, I don't want to say exactly identical, but it goes through the same motions as this entire red shape. So by multiplying our input by 2, we have halved the period. So the period of this function is no longer 2 pi. So if we look at the red one, it repeats, its values repeat after 2 pi. That's what I'm trying to say. So on the red graph, our values repeat after every 2 pi rotation. However, if we look at this purple graph, we get a repeating output after just a pi rotation. So if we look at 2 pi, we also get 1. And if we keep increasing this by pi, we still get 1. So every pi, we get 1 rotation. Okay. So this is the same thing for sine. So sine of 2x and sine of x. So again, from 0 to 2 pi, we get 1 rotation on our red graph, but on our purple one, we get 2 rotations. It repeats after every, oops, sorry. It's probably better to highlight these points. It repeats after every pi instead of every 2 pi. So what happens if we multiply this by a fraction instead of, that's not what I meant to do. What if we multiply this by a fraction instead of a whole number? And what happens is instead of having the period, this is really hard to see. Let me switch back to cosine to see if this makes it a little bit easier to see. And oops, cosine. I'm going to change my range from this to 0 and this time 4 pi. So now the colors are the same as they were before. This red is just our regular cosine. Notice that it repeats after 2 pi. However, our purple, it doesn't repeat until you get all the way to 4 pi. So when we multiply our input, multiply the x in our function by a fraction, we actually increase the period. So by having our input x, we increase the period by 2. Okay. So this may seem a little tricky or counterintuitive, but it's just because if our input on our purple graph is 2 pi, well, that 2 pi gets multiplied by 1 over 2 before you evaluate it. And this, I hate talking without writing it down, so let me grab the whiteboard. So when you have when you have x equal to 2 pi, and you plug it into this equation, what you get out of it is cosine of pi, which is actually -1. And if we look at our graph, that is what we see. Cosine of 2 pi is, cosine of pi is -1. But in this case, our input was 2 pi. I kind of butchered the explanation at the end there, but I hope the meaning came across. So that's basically it, I guess. I think that's it. Hope that's it. That's Desmos, and that's how you can use it in order to help you with these concepts and different things like that. As always, I think there are different plots you can go through with trigonometry. Like they have a period, and here you can keep adjusting. The A here is our amplitude, and B here is the thing we're multiplying x by, so this affects the period and the length of that. So there's also these that you can mess around with and try to get a better handle about these concepts. But as always, let me know if you have any questions. I hope this kind of cleared things up. Hope y'all are doing fine with the homework and everything. And I'll talk to you next time.